So what do we do when we want to find probabilities that do not fall exactly on a 1, 2, or 3 standard deviation mark from the mean? Because of course life is not that simple and that easy. We want to find other probabilities. Technically, we would need calculus to find these areas under the curves, but we have other technologies that can do that work for us. A couple special notes are the words probability, area under curve, percentile, and proportion all mean the same thing. So when you see any of those words, you are talking about, again, that specific slice of area underneath the curve. That is your probability. It's also a percentile or a proportion. Rounding to 4 decimal places for your final, as well as intermediate values, is the most common. So look for a direction on that, but if you're not given direction, then that's my direction to use, round to 4 decimal places. So let's see. Women's heights, we know, are normally distributed with a mean of 64 inches and a standard deviation of 3 inches. But now we want to use technology to find the following and sketch the associated normal curve for each, just to give us a visual of what's going on. Let's find the probability that a randomly chosen woman is less than 62 inches tall. So we think about what this is going to look like. We've got a mean at 64. And again, if we were going this direction, our next mark, 1 standard deviation down, would be at 61 inches. But we're being asked not that, we're being asked 62 inches or below. So we can't use the empirical rule here because we don't fall directly on a 1, 2, 3 or -1, -2, -3 standard deviation mark. We need to use technology. So we've got our Excel commands here. To find a normal probability, we want to use the normal Dist, basically, function. We're going to put in the value that we're looking for, the mean, the standard deviation, and again, whether or not it is true or false for cumulative. In this case, what that's going to look like is we're going to type in equals norm.dist. We're looking for the 62 value, mean being 64, standard deviation being 3, and we are looking for everything up to that 62 mark, right? So it is cumulative in this case. So we're going to use true there. I'm going to go over here and type that in. So you can insert this or you can just type it. We are going to use, oops, wrong box. So we're using the normal distribution, the value 62 for our random variable, mean of 64, standard deviation of 3, and we are looking for everything up to that, so true. So it looks like 0.2525 if we round it to 4 decimal places. And this right here would be what you could show me on your paper for the test. You would show me I'm using this function. These are what I put in for all my values, and here's what I got back. You could even draw the associated curve. That would be optional, but this right here would be the amount of work that I would be expecting to see for full credit. Just an answer would not give you full credit, and especially think, what if this answer is wrong? What if it's because you reversed these 2 values when you typed them in, or something simple like that? If I can determine that you at least knew what function to use, you were trying to do the right thing, you knew the right values, then I can give you some partial credit for that. Okay, what is the probability that a randomly chosen woman is more than 62 inches tall? So we have the same normal curve going on here, mean still at 64. The value in question is still down here at 62, but this time we want the other side. We want more than that. Because we've already calculated less than that, we can just use the complement rule here. If you hadn't already done part A, you would have to do that now because, again, Excel only does the up to direction. So anytime you need greater than, you have to use the complement rule, which is why we learned it. So we're going to do 1 minus the probability of being less than 62 inches, which we happened to already find as being 0.2525. So if we subtract that, we get 0.7475. And that would be enough work there to explain what you were doing and why you got what you got. Find the probability that a randomly chosen woman is between 62 and 67 inches tall. So how are we going to do a between value? So we've got this lower value of 62 and an upper value of 67, and we want to know the probability that a randomly chosen woman falls in between there. So what we're going to have to do, again, because Excel only does the less than direction, first, what we're going to have to do is we're going to have to find the probability that a randomly selected person falls all the way below this 67 mark, all the way down here. So find that entire probability and then basically subtract off this part. We don't want this part. We only want the center part. So we're going to have to find or take the below 62 and subtract that off. Okay, so let's see. What we're going to do is we're first going to do the probability, or I guess I'll write out. We're going to find the probability of being less than 67, and then we're going to subtract from that the probability of being less than 62 inches to find the probability of being between those. So I do need to find the probability of being less than 67. So to find that, I'm going to do a binom.dist, and that is going to be 67 with a 64 mean, a 3 standard deviation, and again true for cumulative. So let's go over here and let's find that. 67, 64, 3, true. Oops, what did I type in correctly? Oop, I typed in that incorrectly. What is it telling me? Let's see if I can get some help. What am I typing in incorrectly here? That's not helpful. Let me just start over again. What have I can't see what I've typed in incorrectly. Let me just clear this out. Oh, it's because I was doing the wrong one. I need a normal distribution. Whoops. Okay, there we go. Normal distribution with a 67 value, 64 mean. No wonder. Of course it's not going to work. I was using the completely wrong formula. Okay, there we go. So this value is 0.8413 to 4 decimal places, and then we're going to subtract off. We've already calculated this value, which is 0.2525. So what I get is 0.5888, which would then, that tells me this probability of being here, because I did the whole thing, subtract off this, leaving me with just this much.